in a conductor, these are what the electrons are kind of doing. They're just bouncing around randomly, just like molecules in the gas. In fact, some people call this an electron gas. What's missing from this diagram or this applet is the protons. We don't see those. But let's just neglect those for right now. So these electrons are just moving around randomly. And the speed that they're moving around very fast, but they're not really getting anywhere. So when this is with no field, when I turn on the electric field, all of a sudden, well, it seems like not much has happened, but if we keep an eye on our purple electron right there, notice it is drifting to the right and takes a long time to get out of the picture, but it will eventually get out of the picture. And here's another electron we can keep track of. It's differently colored, so we can keep track of it. And they seem to be moving randomly again, but you'll notice that it does eventually drift off to the right. And here comes another one. And all these electrons are eventually drifting off to the right. Another example of this is this right here. This is a little bit more accurate in terms of it's got the protons there. It's got a lattice of these nuclei in the metal. Those are the big red dots. And the electrons are just jumping from one atom to another. In a metal, they're really shared by all the atoms. So these electrons don't really belong to any one atom. These are outer shell or conduction electrons. The highest energy electrons in the atom can, in a metal, move from atom to atom freely. So what I have here are some quarters, which are going to represent the nuclei of atoms, and some pennies, which represent the outer orbital electrons in the conduction band. And if I turn on an electric field, as we'll see, this will all make sense, but if the electric field is pointing this way, the electrons will actually be pulled this way. So let's say I'm turning on the electric field and it's pointing this way from this end, and the electric field moves very quick at the speed of light. It pulls this electron off. Now, first of all, I want you to notice that there is now a positive charge right there. There's a hole there. There's a missing electron. When the electric field gets to here, it pulls this electron off, which goes to there, and then eventually gets to here, pulls that electron off. Then it gets to here, pulls this electron off, and it gets here, pulls this electron off. Notice now that the positive charge is right over here. So if we reverse the tape here, started with a positive charge here, and we ended up with a positive charge here. So we can, in fact, say that positive charges move this way. And in fact, in hole flow, in semiconductors, even though it's just a missing electron, quantum mechanically, it is identical to a moving positive charge.